Hello everyone, my name is Andrew He and this is my Math and Peoples project. I chose to do my project on net income because my mother, Cindy, she owns a restaurant business, so she basically uses this formula almost every single day. So the formula is net income equals net revenue minus net expenses. Well, net expenses is the rent, taxes, ingredients, and other stuff that we're not accounting for right now. Net revenue is the total amount of money that we gain from selling food. And if we subtract net revenue and net expenses, then we get our net income. All right, so let's look at this problem. It says McDonald's net revenue for the fiscal year 2023 through 2024 is $2,356,789. The net expenses is a total of $1,120,246. What is the net profit or loss, and how do we know? So we use the equation of net revenue minus net expenses, and we have $2,356,789 minus $1,123,246. This would equal $1,233,543. So our net profit is $1,233,543. And we know this is a net profit because this is a positive number. But how do we know if it's a net loss? So let's look at this equation. It says Burger King made a net revenue of $2,637,892. The net expenses total to $4,692,888. What is a total profit or loss, and how do we know? So using our equation, we use the net revenue of $2,637,892 minus our net expenses of $4,692,888. And our result will be negative $2,054,996. Well, in this situation, since this is negative, we know we have a net loss because it's the negatives. Of course, these are all made up numbers and are not representative of the real life situations. Now let's look at our next equation. All right, so this is our next equation. Net expenses equals net revenue minus net income. Well, in what situation will we use this equation? All right, so let's look at this equation. It says McDonald's has a net revenue of about $2 million and a net income of about $500,000. McDonald's wants to know what is the approximate net expenses. Okay, we'll plug in our net revenue of $2 million and our net income of $500,000 to receive our net expenses of $1.5 million. The reason we will use this situation is if the specific restaurant knows how much they make and how much income they get yearly. Well, this is my Math and Peoples project for Math 171. Thank you so much for watching. Bye.
Hi, this is my Math and People project. So for my project, I decided to use molarity. Molarity is something we often use in chemistry. So the person I decided to interview for this was Dr. Mary Ann Evans. She is a professor for chemistry at RCC. So basically, she uses this in her career to measure out concentrations of various things she might give us. So if she decides to give us a certain amount of hydrochloric acid, she's not going to want to give us a completely concentrated substance. We probably wouldn't need all that anyways, but she uses a molarity formula in order to dilute certain concentrations in order to get what we need for our labs. So basically what molarity is the moles of a substance over the liters that substance is being put into. So like I said with hydrofluoric acid, we take the moles of the hydrofluoric acid and divide it by the liters of maybe, let's say, the water we're putting it into to get the molarity. So one thing to know is that moles is essentially a unit of measurement for mass. It's not quite the same as grams. It's very dependent on what you're using, but that's just the general rule. Another rule about this problem is that every time you divide, no matter what, you have to use liters. If you don't use liters, you'll get it wrong. But anyways, I'm gonna show you the example that I decided to use, taken from the chemistry textbook. So it reads out, a 355 milliliter soft drink sample contains 0.133 moles of table sugar. What is the molar concentration of the beverage? So the first few things that we need to remember is that we cannot use milliliters in this equation, so we'd have to take 355 milliliters and convert it into liters by dividing by 1,000. After that, we can basically solve the entire equation. It's not very intense. So this is what it would look like. We have 0.133 moles of sucrose divided by 0.355 liters of the beverage to equal out to 0.375 m, which stands for molarity. And that's all. Thank you for watching.
My name is Azariah, and today I'm going to show you how math is used in the career of my mom, who works in human resources for a manufacturing company. So in my mom's job, she needs to do a bi-weekly payroll to calculate how much money every employee is entitled to. For example, we might have Sally, who's supposed to get paid this week, and we need to know how much money she needs to receive for a bi-weekly payroll. So we have to figure out how many hours she worked, what her pay rate is, like how much money she made per hour, and the overtime worked, and also the tax and benefit deductions. So first of all, we know that Sally makes $25 an hour, and she normally works 80 hours over the course of 2 weeks. So 25 times 80, I did the math for you, is $2,000. Next, my mom determines the overtime pay Sally incurred. To do this, she calculates the overtime hourly rate by multiplying the regular hourly rate by 1.5, which is 37.50. So 25 times 1.5 is $37.50. And she worked 10 hours of overtime. So that's $37.50 times 10 is $375. $375 plus that $2,000 is $2,375 gross pay. Now, with tax and benefit deductions, you'd take that 2,375 and subtract it by 550, and that gives you $1,825 for her net pay, Sally's net pay, that she actually made. So, in conclusion, by solving this problem, my mom can make sure that Sally gets the right amount of money in her paycheck, which helps keep everyone satisfied. And this shows how math is important in her career. Thank you.
My name is Colton Brown, and this is my Math and People Project presentation video. So for my presentation, I chose finding the final gear ratio on my race car. And with that, I had 10 over X, with X being the output of my transmission, times 10 over Y, which Y is the output of my rear end gear, gives me my final drive ratio on my race car. So if you have all the values for my race car, it'd be 10 over 4.67, which is the output of my transmission revolutions, times 10 over 3.24, which is the output of my rear end gear, equals 6.59, which is the final drive ratio of my race car. But I didn't have all the values when I was doing this, so I had to go backwards, because I had the final ratios for each of the two, but I didn't have the actual X and Y. So I had 2.14 as the final ratio for my transmission. So what I ended up having to do was do 10 over 2.14 to get the value for this. And then to find the value of Y, I had to do 10 over 3.08, which was the final gear ratio of the rear end gear. So when you put all these together, you end up getting this problem here, which gives 6.59 as the final drive ratio. And that was my formula in my presentation for the Math and People project.
My name is Ginger Denson. I interview Michelle Denson, who's the education director at Premier Real Estate at Sand Hills. I'm just going to kind of talk about how real estate and math play into each other. So every realtor really needs to know how to find what they're going to make off a house with commission. In this specific case, we're going to talk about a house that costs $750,000 in Southern Pines. Okay, so this house is $750,000. Skip for that. Okay, and in this contract specifically states that Premier is going to get 2.5% of that sale price. Okay, so we're going to solve for that real quick. So $750,000 times 2.5%, written out as 750 times 0.025. The answer to that is 18,750. This is how much Premier is going to get when the house sells. But Premier's not the agent. Premier has an agent that worked directly with this house, so now they have to pay them. So Candy is the agent that worked with this house directly. Candy is going to get 97% of this 2.5%. Okay? So we're going to do that really quick. So that'd be 18,750 times 0.97. This is a 2.5%, so 97 that. Okay? Now the answer to this is 18,187.50. This is how much Candy would get paid before taxes.
Hi, my name is Lexi Brewington, and for my math project, I interviewed my aunt, Alice Hall, and she works as a church's accountant. As a church's accountant, she works on the finances of the church and makes sure they match up towards the bank statements and everything. And two formulas that she uses is depreciation and appreciation. For depreciation, that is the decrease in value of an asset over time. And the formula for that is the cost of the asset subtract the salvage value divided by the useful life. An example of this would be they buy like maybe a van for the church for 20 grand, and the salvage value would be 50 grand after 5 years. So when you use the formula, you would do the 20,000 subtract the 50,000 over 5, which is 5 years, and you get, it depreciates 30,000 per year. For appreciation, that's the increase in the value of an asset over time. So the formula for that would be current value subtract the purchase price, and divided by the purchase price times 100%. An example of that would be the church's value would be like 250,000, and after 10 years the value increases to 350,000. You would do the 350,000 subtract the 250,000 over the 250,000 times 100%, and you would get it increases 40% over 10 years. Overall, appreciation and depreciation are important for the finances about what decreases in value and increases in value, like the property and the vehicles. And that's all I have to say for today. Thank you very much.
Hi, my name is Logan Locklear, and I will be teaching you about absolute change and proportional equations, and how my mom helped a 7th grade student figure out those two equations with real life examples. So my first example is a store sold shoes for $10. Last month they sold 50 shoes, and this month they sold 65 shoes. And we are trying to find the absolute change for how many shoes they sold in total. So 65 shoes sold this month minus the 50 shoes sold last month equals 15 shoes. And the answer 15 shoes, that's the absolute change. Alright, for the proportional equations, the formula is proportional increase equals original value divided by absolute change times 100. And I use the same numbers from the last equation with this equation. So proportional increase equals 15 divided by 50. 15 is the last answer, which was the 15 shoes. And then I got the 50, which was the 50 shoes last month. So I did 15 divided by 50 times 100 equals 30%. So the 30% is thus shoes sold. They sold 30% more shoes this month than last month. And that is it. Thank you for watching, and I'll catch you in another video.
Hello everyone, my name is Madeline Burnett, and today I'm here with a lieutenant from the Navy.
Hi Maddie, I'm Lieutenant Danielle Dixon. I am currently stationed on board the USS Truxtun out of Norfolk, Virginia.
Today we are going to be using math to explain how the U.S. Navy travels across the ocean.
Sometimes we just have to break out the maps, some pen and paper, and get down with old school math, especially when it comes to navigation and navigating safely.
Exactly. So let's grab our pen and our paper and let's show the public how we do it. So for this equation, we're going to use speed over distance and time. So that would be speed equals 537 over 24. That's our time, which would equal 22.37. So that's roughly about 22 miles per hour.
22 knots, Maddie. It's the Navy.
22 knots.
Exactly. So you calculate that perfectly. That's exactly how we would do it on the bridge. For problem number 2, so now we've picked up our helo deck and we're doing our mission. We're going to take them back to Mayport, drop them off, and we're going to go back home. But unfortunately, our ship suffered a major engineering casualty and we can only go 15 knots. How long will it take us to get home? When should we tell the tugs to meet us outside of Norfolk?
So for this version of the problem, we would have to calculate time. So that would be distance over speed. So if our distance is the same of 537 and our speed was 22 knots.
Well, that was our speed coming down. We want our speed to go back because remember we suffered that casualty. So we can only go 15 knots.
So let's change that. So that's 15 knots. 537 divided by 15 would be 35.8 hours, which technically would be 1 day, 11 hours, and 48 minutes.
Exactly. And that's important for us to have exactly that time so that we can let our people on the Norfolk base know when to have the tugs to come out and meet us, because we can't just drive this ship in. It takes a lot of different partners to get us in safely.
By any chance, if I was wrong on these calculations, what would happen?
So if we have multiple people that run the same calculations, we do them multiple times throughout our journey to make sure that we're right. We have computers that back us up just to make sure if there's a discrepancy. But at the end of the day, if you're wrong and you just show up late, you just have to communicate and let the tugs know so that hopefully they'll wait for you.
Well, thank you so much, Lieutenant Dixon, and thank you for serving our country.
Thank you, Maddie. Have a great day.
Bye.
Hi, my name is Melanie Garcia, and this is my Math 171 project. So first, I'm going to start off by showing you an interview of me interviewing my Business 110 professor, Kelly Beam.
Hi, my name is Melanie Garcia, and I'm here with my Business 110 professor,
Kelly Beam, Mrs. Beam.
So, Mrs. Beam, what businesses have you worked for?
I have been lucky enough to get to work for many businesses and several different types of industries, food and manufacturing. My favorite job though was with Pepsi, and I got to be a production planner for Pepsi.
That's good. So what kind of math did you have to do for Pepsi?
So everything, a lot of math, even though it was very simple math. So a lot of pluses, minuses, division, that kind of thing. Basically, it's just a lot of simple math, tying it all together.
Okay, so I'm not going to use a typical word problem, but I'm going to solve out a scenario that Mrs. Beam had to solve out constantly. So what's the scenario?
Miss Beam needs to prepare a shipment of Pepsi. She must calculate how many truckloads are needed to fulfill an order of 5,000 gallons of Pepsi drinks.
Okay, so first let's figure out how many cases there is per pallet. And each pallet was 12 cases high and then 12 cases lengthwise. So when you multiply that, you get the number 144, which meant there was 144 cases per pallet. But then to find the number of cans, we multiply by 12 again because there's 12 cans per case, and we get the number 1,728. Okay, so next we have to figure out how many ounces of liquid there is per pallet, and we already know that there's 1,728 cans per pallet, and there's 12 ounces of Pepsi drink in every can, and when we multiply that, we get the number 20,736, meaning there is that many ounces of liquid per pallet. Okay, so next let's figure out how many gallons there is per pallet, and we already know that there's this many ounces per pallet, and there is 128 ounces per gallon. So when we divide the two, we get the number 162, meaning there's 162 gallons per pallet. Okay, so as mentioned earlier, the regular 5,000 gallon batch is 5,000 gallons, and when we divide that by the gallons of per pallet is 162, and we get the number 30.86, which means that Miss Beam needs 31 truckloads to fulfill her regular Pepsi shipment order. I hope you enjoy my Math 171 project.
Hello everyone, my name is Natalie Ludlam, and this is my Math and People project for Math 171. I chose to do my sister, Jessica Ludlam, who's an accounting tech. She uses math in her everyday life. She determines how much funds a company has, adds up taxes, counts the money, things like that. An example of one of the problems she would do is if another company provided reimbursements for accounts. So let's say they give 4,326 to account 701, 2,500 to 702, 1,200 from 703, and 1,600 from 704. Now fees also have to be taken into account when doing it. So let's say they take 4151 from 701, 1612 from 702, 316 from 703, and 2420 from 704. Now we have to find out how much funds each account has. Jessica gave me the formula funds equals reimbursement minus fees. So we would use these for each account. So for account 701, we would take the reimbursement, 4,326 minus the fees, 4.31, and to get the funds would end up being 4,284.69. For account 702, it would be 2,500 minus 16.12 equals 2,483.88. For account 703, we would do 1,200 minus 3.16 equals 1,196.84. Then account 704 would be 1,600 minus 24.20 equals 1,575.8. And so now we would have funds for every single account. Another example of the problem Jessica uses is, let's say you have a receipt with 4 items. One costs $16.99, one costs $13.98, one costs $25.49, and one costs $4.99. So now we also have to take account the tax, which is $5.99. And to clarify, these numbers are made up and they're not actually real. And the shipping and handling would be $6.99, which you also would have to take into account. So now we need to find the total cost of a receipt. Now Jessica gave me the formula total equals price plus tax plus shipping and handling. So in this chart right here, we have the price of each item, the price of a tax, and the price of a shipping and handling. So all we have to do is add all of these together. So once you add all of them together, your total will be 74.43. Well, that's it for my Math 171 Math and Peoples project. Thanks for watching. Bye!
This is my dad, P.T. Dawkins, and he works for the Richmond County Sheriff's Department, and he's going to explain how math connects to his career.
All right, hey, good morning. I'm going to explain to you how we convert grams into ounces in my line of work. So say, for instance, this is used mainly by our narcotics officers when we get drugs. Drugs a lot of times are weighed in grams and ounces and kilograms and so on and so on. So in order to convert something from an ounce to a gram, we got to know this. 1 ounce we know is 28.34 grams. So let's just say a particular officer stops a car, they have 400 grams of cocaine. Well, say if we want to convert that to ounces, it's a pretty standard formula. 1 ounce, like I said, is 28.34 grams. So if we have 400 grams, we'll just divide 400 by 28.34, and that equals 14.11 ounces. So if you got 400 grams of any alleged narcotic, that will equal 14 ounces of that particular drug. And you do the same, for instance, if you had, let's just say 14 and a half grams. Divide it by 28.34, and that'll give you 0.51 ounces. And typically, the grams are used for smaller size narcotics, and the ounces are used for more larger quantities, and then it goes on to kilos and so on and so on. But this is just a common formula that we just use in our day-to-day practice in the law enforcement world. Hope this helps you guys out.
Thank you.
Thank you.
So as you can see, math is actually very important to many cops, as they have to do exact measurements for many drugs that they find off of people, just because they want to get the most precise measurement to see how much they have. So I'm going to show you how they do that. So 1 ounce is equal to 28.34 grams. Let's just say that they had 14.5 grams of a drug. You would divide that by 28.34, and that would give you 0.51 ounces. Now, this is approximate, but this is usually how they do it. They will just usually round it to the second decimal place or something like that, and that's just how they get it the most exact.
Hi everyone, my name is Samara Alshife, and this is my Math and People project. For my person, I chose Donald Mitchell. He works as a construction superintendent. Mr. Mitchell states many of the duties of a construction superintendent require extensive use of math. In this career, the superintendent oversees the architect as well as all of the laborers. Math is used by the architect when calculating the square footage of a lot and square footage of each building, along with drafting out the correct scaling on a plan for where specific walls and other details will go. Others who use math in this job are graders that add or remove dirt, cement workers that pour the footers, framing laborers, drywall workers, roofing, electrical, and plumbing professionals, punch carpenters, and even landscapers. The owners of the construction business even use math to project completion dates. As Mr. Mitchell states, math is a must in this career. I even use it to make sure people are putting things in their exact designated spot and to budget and keep everything flowing. One example of a math problem that relates to this profession is the preparation of pre-construction estimates for use on the job. For example, a roof is 8,800 square feet. 8,800 will be divided by 100 to get 88 squares of shingles. Generally, one would order 3 bundles per roofing square. Most companies or individuals usually order slightly more than is thought to be needed. Asphalt shingles are about $6 per square foot, so our 8,800 square foot roof would be calculated by figuring 8,800 times 6. This would cost approximately $52,800 just for shingles. Plywood, underlayment, and rafters are not included in this problem. Then an additional 10 to 15% is added to that estimation for waste, fees, and cleanup. Waste and cleanup would be roughly another $5,280 to $7,920, thus bringing the figure up. $52,800 plus $5,280 equals $58,080, and $52,800 plus $7,920 equals $60,720. These dollar amounts are an accurate calculation for purchase of shingles, material, and waste cleanup.
So my problem is my dad measures the inside diameter and that of the hydraulic cylinder, and that equals 1.50 inches. Then he has to measure the width of the seal, and that equals 0.25 inches. Then he multiplies that by 2 and adds it to his ID to get his outside diameter. What is the outside diameter of the seal? So you start off with just leaving 1.50 in the corner. and then you have to then he takes the 0.25 and multiplies that by 2. And then he adds that to his ID, which gets 1.50, which equals 2.0. And then, so you have to find the outside diameter, and that's going to equal 1.5 inches by 2. And he uses that right there to replace the bad seal of the hydraulic cylinder.
How y'all doing? My name is Tyson Fowler, and today I'll be doing my Math 171 project. The person I interviewed today was my mom, so now I will insert a clip of my mom.
My name is Shannon Fowler. I'm the customer service manager for the city of Hamlet. We distribute water bills monthly and tax bills yearly to customers, and they come in and they pay their utility service or their taxes in our department. If they have problems with their water and need some assistance, we help them find problems, and we use adjustments to help calculate a reasonable water bill for the customer if they fall in the right category of our policy.
Since she deals with water bills, why not do a water bill problem for my project? I'm dealing with inequalities and world problems today, and without further ado, let's hop right into it. Can you please read the problem?
James receives his monthly water bill, which starts with $20 and an additional charge of $2 for every 1,000 gallons of water he uses. He wants to keep his total bill under $50. Write an inequality to represent the number of thousands of gallons that James can use to keep his bill under $50. Solve to determine the maximum number of gallons of water James can use. James calls customer service about a new plan that offers a $5 discount if he signs up. How many thousands of gallons can he use while still keeping his bill under $50 with the discount?
Thank you. Let's hop straight into the problem. To set up the inequality, we can write it as 20 plus 2x is less than 50. From here, we subtract 20, leaving 2x is less than 30. Divide by 2, x has to be less than 15. Knowing that James had to use less than 15,000 gallons, we will now include the discount that we will provide. Problem would be 20 plus 2x minus 5. It's the same problem from before, but we just included the discount. 20 minus 5, that's 15. Subtract 15. And then we're gonna divide by 2, making it x. This right here is saying that you can't fully use 18 gallons, so you have to get what you can. So he can't use more than 17 gallons. Thank you guys for watching my presentation, and I'll be signing off.
Hi, I'm JP Hancock, and I'm an engineer at CSX. William wanted me to go over a synopsis of how I use math daily in my job. Here are the totals of my train, and I was instructed to set off 4 cars, and I subtracted the information in from those 4 cars, the tonnage and the length, from my grand totals to give me what I had remaining after I left McCall, South Carolina, and made our set off. I set off 1 load, 3 empties, 250 tons, and 260 feet and 16 axles. I made those subtractions here from my grand total to leave me this for the entirety of my train going into Florence.
Starts off with having to find the length of the set-offs that he dropped off. So he has 408 originally, and he subtracts 74, but he subtracts 2 of those to give him 260. The 74 is the engine length, and the 2 is the number of engines. So he has that, and his given number is 6,966. Subtract the 260 because that's how much he drops off, and gives him 6,706 feet still left of the train. So then he has to find the tonnage of the train, and the given tonnage is 9,724 tons, and he subtracts 250 tons, and that leaves him with 9,474 tons of train. And both these numbers are found in his paperwork that he's given at work. And then he has to find the number of loads on the train. So he's given 56,
drops one off, so now he has 55 loads. And then he has to find the number of empties on the train, and he's given 74, drops off 3, so now he has 71. And then he has to find the number of axles on the train, so he dropped off 4 cars. Each one of those cars have 4 axles, so that gives him 16 axles dropped off. So his given number of axles was 520. Subtract the 16 dropped off, and that gives you 504 axles still on the train.
Hello everybody, my name is Willie Charles Breeden Jr. and I'm doing my Math and People project video right now. Now, when I came trying to find a person for this topic, my first thought was my dad. He is one of the most influential people in my life, and his name is Willie Charles Breeden Sr. So, these are some pictures of my dad, and if you're wondering why my hair looks so bad, this is a picture of a fresh cut. I just don't take care of my hair. He does that all for me. My dad always talks about how he's such a bad mathematician. He wasn't very good in school, but he is a true artist when it comes to hair. But with that artistic mind of a barber, he knows the greatest math equation of all, profit. So how does he do this great miracle of profit, which gives him so much money and gives me so much money? Well, it takes this equation, P equals TS minus C, which is profit equals total sales minus cost. For your total sales, that's going to be your items times your cost of the item times your people that's selling it. So haircuts are $20, slams are $30, eyebrows are $10, right? Let's say 70 people are going to get haircuts, 40 people are going to get slams, and 50 people get eyebrows. And that's just for 1 month. Let's say it was for 1 month. That will give you $3,100. But now we need to find our cost. Your costs are going to be somewhat more constant than your total sales, because you can somewhat predict that. Bills are constant at a location for the most part, and that's around $206.25. Then there's a random variable of X, which can be anything from paper towels to razors to new hair products that he needs to buy. So let's just say for the month, he needs to buy some candy to attract some customers. I don't know. That's like $50, all right? That will give you $256.25 in cost. Now we know our total sales and our cost. Put it all together, minus it. 3,100 minus 256.25 gives you $2,834.75. That is a lot of money for 1 month. I hope you enjoyed this video. Remember to go check out Breeden's Barbershop, which is where my dad works at. Goodbye.